Linear models. The word model implies that there was an investigation or some research done. Some data was generated, and now we would like a line to model the data. In other words, a line that will represent all the data, that will approximate all the data. Here's the line, and those points you see are the data. These 3 points that are on the line, these 3 data points are represented by the line perfectly. The points that are not on the line are represented by the line with an error. There's an error in the representation. The closer the point is to the line, the better the line can represent it. And the further the point is away from the line, the less the line can represent it. The closer the point to the line, the better the line can represent the point. So our objective is to find the line that gets closest to the most amount of points. You could draw a line through any 2 points. So there's many lines you could draw here. But out of all those lines, there's one that gets closest to the most amount of points. That's the line we're looking for. That line is called the line of best fit. The line of best fit is the line that gets closest to the most amount of points. To find the line of best fit, the distance between the point and the line need to be determined. This is done by subtracting the y-coordinate of the point on the line. Notice the point on the line is going to have a little hat, the y-coordinate, and the y-coordinate of the data. The y-coordinate of the data doesn't have a hat. So this y is data y, and this y is line model y. This difference represents the distance away from the line. So here's our data point. Here's the point on our line model. How far apart are these y's? Well, that would be that subtraction. This subtraction has a name. It's called the residual. It's the error because it's distance away from the line that's trying to model the point. Find the residuals for the following data. So each one of these is a point. Here's our data. Let the x equal 6 for 2006. So 2008, x would equal 8. 2010, x will equal 10, and so forth. So x, y, x, y, x, y, x, y, x, y. This one's going to be the linear model, the one that's trying to represent this table. So from the table, these are the points. Remember that 6 represents 2006. The 8 represents 2008. So these are our x's, here are our y's. Our linear model, this is the line that's trying to represent the data. So you put the x from the data in the equation, and it's going to produce a y-coordinate for the linear model. So this one has its y's, and with the equation, we're going to produce the other y's, the ones that belong to the line. Then we're going to subtract those 2 y's. So we subtract these 2 y's. These 2 y's are subtracted. And that's going to be our residual. Notice we're subtracting those 2 y's. And we get what we call the residual. And then we add them. This is called the sum of the residuals. But there's a problem here. These numbers could have been negative, and they could have been equal numbers with opposite signs, and they would have canceled, and we would have lost that information. In order not to lose information, what we're going to do first is square these. That assures that the number is always positive, and then add them. So we have the sum of residuals. So now we're going to square each one of these and then add those. So we did the subtraction, we square those numbers. Now we add them and we get sum of squares. This is the number that we're going to keep. This number represents how much error there is in letting that line represent the data. So we call this the sum of squares. So this is like a grade that the line is getting. This line got a 73.06. If there's another line and it gets a 50, that means it has less error and that you would pick that line instead. So you pick the line with the least sum of squares. That would be your better line. So right here, we'll remember that it's possible that in adding the residuals, the sum may be 0. Therefore, in order not to lose the information on how accurate the line equation represents the data, the residuals are first squared and then added, which is a sum of squares. Conclusion, the line that has the smaller sum of squares is the better line to represent the data.